In the next example, we want to find the antiderivative of f of x, where f of x equals to 4 secant squared of x minus 6x squared, with f of 0 equal to 0. So we are looking for a very specific c value. Now, if you go back to your list of integrals, the integral of secant squared x dx is tan x plus c. Okay, so we have 4 secant squared of x minus 6x squared. So what we're going to do is we're going to take the integral of that. Now, for secant squared of x, the integral is tan x according to the formula. So the integral of secant squared x dx is equal to tan x. And then because we have a 4, that 4 is just going to be the constant. And then secant squared of x is an integral of tan x. So big F of x, which is the antiderivative, is first part is 4 tan x. Now the second part, we're going to use the power rule of integrals. So if you have the integral of x to the n dx, that equals to x to the n plus 1 over n plus 1 dx. Okay, so we have negative 6x to the 2 plus 1 over 2 plus 1. And then if you simplify that, we get negative 6x cubed over 3. And then if you reduce 6 and 3, we get 4 tan x minus 2x cubed plus c. But we're not quite done, because anytime you're given a specific point for big F, which is the antiderivative, you got to plug it in. So the x value is 0, the y value is 0. So we're going to have 0 equals to 4 tan of 0 minus 2 times 0 cubed plus c. You can use a calculator to find the tan of 0, or you can use a unit circle. So this is going to give you 0 minus 0 plus c, because 0 cubed is 0. And we're going to get c equal to 0 as well. So our specific function is going to be 4 tan x minus 2x squared. And we don't have to write the plus 0, which is why it is not there. All right, next example, we want to consider the function f of x whose second derivative is f double prime of x equals to 7x plus 4 sine of x. And now we're given f of 0 is equal to 2 and f prime of 0 is equal to 2 as well. We want to know what is f of 3. So this is going to be an involved problem, because notice we have the second derivative. So we're going to take the second derivative and take the integral twice in order to get to f of x, which is the original function. So let's start with the second derivative, which is 7x plus 4 sine of x. That is the second derivative. So the first derivative will be the integral of that second derivative. Okay, now for 7x, all we're going to be using is the power rule for integrals. So that'll be 7x to the 1 plus 1 over 1 plus 1. And then the integral of sine of x, we can go back to that list of trigonometric integrals, which is over here. The integral of sine of x is equal to negative cosine of x, plus c, of course. So let me write that down on the side so we can reference it. The integral of sine x dx is equal to negative cos x, and then you got the plus c. And then for the 7x, we just use the power rule. If you simplify this, we get 7x squared over 2 minus 4 cos x plus c. However, we're not done, because we have to find out what c is. Now, we're given that f prime of 0, so for the first derivative, f prime of 0 is equal to 2. So we're going to replace the y value, or the f prime of x, with 2, and the x values with 0. So we have 7 times 0 squared over 2. 0 squared is 0. 0 times anything is 0. So that we can just ignore. And then cosine of 0 is 1. You can look at the unit circle, or you can look at your calculator. So negative 4 times 1 is going to be negative 4. And if I add 4 to both sides, I get c is equal to 6. Which means that my first derivative is going to be 7x squared over 2 minus 4 cos x plus c, which is going to be 6. From there, we need to keep going, and we need to integrate this one more time in order to find the original function, f of x. So if I integrate this, I have 7 over 2x squared minus 4 cosine of x plus 6 plus dx. And so for the x squared, I'm just going to use the power rule, but 7 over 2 is a constant. So I have 7 over 2 times x to the 2 plus 1 over 2 plus 1. It's just going to be n plus 1 over n plus 1. And remember, 7/2 is separate, so we keep that as the constant. Now the integral of cos x dx, you can once again look at your trigonometric rules of integrals. That'll be sine of x plus c. So cos x has an integral of sine x. Now, if you have 6, remember anytime you have just a constant, the integral is just going to be ax plus c. So for 6, it's going to be 6x. And you got that plus c. Let's simplify this. We have 7 over 2 x cubed over, now this is going to be x cubed over 3, right? So you have your 2 times 3, which is going to multiply to 6. But we're not quite done because we still want to find out what c is, and f of 0 is equal to 2. So I replace the y value with 2, replace all the x values with 0, and then all of these are 0, 0, 0, so we get c is equal to 2, and this becomes our final function. And then finally, we want to know what is f of 3, so you replace the x value with 3, and you get 50.9355. Okay, next we have the graph of f of x that passes through the point 3, 4, and the slope of the tangent line at that point is 6x plus 7. What is f of 4? Okay, so let's break this down. First of all, what is the slope of the tangent line? Remember, the slope of a tangent line is just f prime of x. So we're told that the slope of the tangent line at that point is 6x plus 7. Okay, so let's start with that. Okay, so we have f prime of x, which is the slope of the tangent line, is equal to 6x plus 7. Now, if we take the integral of that, which will give you f of x, we're going to use the power rule. And so once again, remember that the power rule, I'm going to have that on every page so we don't forget it. The power rule of integrals is going to be x to the integral of x to the n is x to the n plus 1 over n plus 1. And then you got the plus c. And then if you have just a constant like 7, then the integral of just a constant is equal to ax plus c. All right, and then we are now going to take the integral of this. So we have 6 to the x plus 1 over 1 plus 1. So your n value is 1. So we have the 1 plus 1 over 1 plus 1. 7, according to this, is going to be 7x plus c. So if you simplify this, we get 6x squared over 2 plus 7x plus c. And then 6 over 2 is 3. So we're going to get f of x equals to 3x squared plus 7x plus c. All right, but we need to know what c is. So what do we do there? Well, we know the point is 3, 4. So we're going to replace the x value with 4. The y value with 4 and the x value with 3. So 3 squared is 9. 9 times 3 is 27. 7 times 3 is 21. If you add those, you get 48, and c is equal to negative 44. So we're going to get f of x equals to 3x squared plus 7x minus 44. And then once we have that, we want to know, we actually want to know what is f of 4. So once we have our function, replace the x values with 4, and we get 32 as the answer. All right, last example, it says a ball is shot from the ground straight up into the air with an initial velocity of 45 feet per second. Assuming that the air resistance can be ignored, how high to the nearest hundredth of a foot does it go? And the acceleration due to gravity is 32 feet per second squared. Okay, let's break this down. So we know that, so remember that, okay, I'm going to start here. So let's say we have a position function s of t. So s of t is going to be our position function. Then s prime of t is going to equal to velocity, which is the speed. And then the second derivative of the position, so s double prime of t, which is equal to v prime of t, this is equal to acceleration. So velocity, this thing, is going to be the integral of acceleration because the first derivative of velocity is acceleration. So the integral of the acceleration is going to be your velocity. So because we're given the acceleration function, which is a of t, its integral will give you velocity. Okay, so we know that the acceleration is 32 feet per second squared. And because when something is falling toward the ground, it has a negative acceleration because it's coming toward the ground, which is why we have a negative 32 dt. And notice it's dt because it's with respect to time. It's per second squared. So we're measuring the acceleration with respect to time, which is why we have a dt, not a dx. So velocity with respect to time is the integral of the acceleration with respect to time. And we also know that if you have a constant, the integral of a is going to be ax plus c. So in this case, if you have negative 32, it'll just be negative 32t plus c. And in this case, it's going to be t and not x because we're taking the derivative with respect to t and not with respect to x. All right, so what happens next? Well, we know that the initial velocity is 45 feet per second because it says right here, the initial velocity is 45 feet per second. So v of 0 is equal to 45. V of 0 just means the initial velocity when time is equal to 0. So we're going to use that in order to find what c is. So we have 45, which is the y value, equal to negative 32 times t, which is 0 plus c, and c is equal to 45. So v of t is equal to negative 32t plus 45. That's your velocity function. Okay, but we don't want just the velocity. We want the position function as well. So s of t, which is position, is going to be the integral of velocity because s prime of t is equal to v of t. So s of t is equal to the integral of v of t, or of velocity. So the position function s of t is equal to the integral of negative 32t plus 45. Here we can use our power rule of integrals. So we have negative 32t of 1 plus 1 over 1 plus 1 plus 45t plus c. So again, for 45, I'm using this rule over here. And I should actually, to use proper notation, I should say a dx. So from there, if I simplify this, I'm going to get negative 32t squared over 2 plus 45t plus c. And then if you reduce this, we get negative 16t squared plus 45t. And then c is going to be the initial position. But the initial position is 0 because if time hasn't started, the particle isn't moving anywhere. Or in this case, it's the ball. The ball isn't moving anywhere. So the initial position of the ball is going to be 0. So our position function is going to be negative 16t squared plus 45t, and 0 we can ignore. Now, what does the question actually say? It says, how high does it go? So the maximum value of this function, s of t, is when the first derivative of that is equal to 0. So the first derivative of this is going to be negative 32t plus 45 equal to 0. And then t is going to equal to positive 45 over 32. So if you subtract 45 divided by negative 32, we get 45 over 32. And then if you plug it in, we get 31.64 feet if you plug in the time into the position function. Long lesson.